kinins and the prostaglandins do, and the leukotrienes. These are all chemical signals that are released by the basophils, or a mast cell. So phagocytes move, neutrophils that move to the site of inflammation adhere to the endothelium of blood vessels. That's called margination. So they squeeze in between those. And so when you have monocytes that go by chemotaxis to the area of injury, and they then will also squeeze through those blood vessels, they perform the majority of the phagocytosis. So if we talk about transplant anti-rejection drugs, these can destroy these innate immune defenses because we don't want them to attack that foreign tissue. Pus damage dead cells or dead macrophages. So when you have, typically a macrophage can phagocytose about 20 times and then it dies. So then it becomes pus. So this just shows you the squeezing through. This shows you what a scab is. Fever is an abnormally high body temperature, so that's non-optimal temperature for a pathogen. We're set at 37 degrees, so obviously a fever is going to go above that. Gram-negative endotoxins cause phagocytes to release interleukin-1. Interleukin-1 is a pro-inflammatory and also increases the ability to cause fever. And so what happens is you have the increased rate of metabolism and shivering occurs, which raises your temperature. You have vasodilation and sweating, and your body temperature falls, which is when you go into crisis. So the goal of the fever is to make it not optimal for the pathogen. However, if the fever becomes so acute and high that you are now suffering, you can go into crisis. Again, we talked about this already. So the complement system is a serum proteins activating the cascade. So these are antigen-antibody reaction. The complement system always causes opsonization, which makes coating the pathogen with the complement protein so that it can be easily phagocytosed. Inflammation is caused by the complement system, which is vasodilation, and MAC, which is membrane attack complex. So that's the three things that the complement system does. So how do you actually, and this just shows you how you cause inflammation. It's going to be a master basophil binding the complement, which releases histamine. So classical pathway for complement activation, antibody binds to the pathogen. The antibody then can bind to complement. Complement then goes through cleavage, and there's opsonization, cytolysis, or inflammation. And so when we talk about these free-floating antibodies, we are talking about IgG. Just bring that back to our chapter 18. So the alternate pathway does not involve antibodies. It involves these protein factors. The protein factors bind to the PAMPs on the surface of the pathogen. They then bind to the complement system on the other end, and that causes the three things that we know. So the lectin pathway, lectin, which is made in the liver, binds to mannose, which is constantly found on the surface of pathogens. That lectin can then bind the complement proteins, which leads to the cleaving cascade, which is opsonization, cytolysis, and inflammation at the end results. And so this just shows you that if you have mannose bound, you can bind a whole bunch of the complement system as well around it. So opsonization, covering the pathogen with complement protein. Phagocytosing macrophages have receptors for binding complement protein. Therefore, difficult to phagocytose pathogens can be bound by this complement bound. So here's my little circles which represent the complement. I now have receptors that bind to the complement, so now I can bind to the pathogen whereas I couldn't previously, so now I can phagocytose it. That's what opsonization is. So some bacteria can get around that complement binding, so capsules, obviously. Carbohydrates prevent the formation of the MAC complex, so now you can't make the holes in it. And you can even have some that do make an exoenzyme that will digest complement proteins and therefore render the complement proteins useless. So the interferons are cytokines. These are chemical messengers. These cause neutrophils and macrophages to phagocytose bacteria. They also recruit them in there. They also cause inflammation. and so that causes vasodilation. This slide is not on the exam. This slide is not on the exam. That is chapter 17.